You've probably played around with an AI like ChatGPT, right? You type in a question, and boom, a whole paragraph appears in seconds. It feels like straight-up magic. But what is actually going on under the hood? Well, today, we're going to pull back the curtain and follow the entire journey, step by step, from your prompt to the AI's final text.
So let's get right to it. How does an AI actually write a sentence? Now, here's the thing you got to remember. It isn't thinking or feeling like a person does. Not at all. Instead, it's running a really precise and honestly fascinating program. So let's break down exactly what that program looks like.
To wrap our heads around this, let's think of it like a digital assembly line. First, we'll look at the learning brain, which is where the AI does all its training. Then, we'll see how it takes our words and turns them into numbers. After that, we'll explore the magic of how it understands context. Then, peek at the prediction engine that chooses the next word. And finally, see how it puts the whole shebang together.
All right, first stop on our assembly line, the learning brain. See, before an LLM can write a single word for you, it has to go to school. And I mean a huge school. So what's the curriculum? Well, the model basically swallows a giant chunk of the internet. Books, websites, articles, you name it. It uses this really powerful blueprint called a transformer model, which is amazing at one thing, finding relationships in data. And this is super important. It's not memorizing pages from a book, no. It's learning the statistical patterns, which words usually follow other words, the hidden rules of grammar, and all the little connections that create meaning.
Okay, so the AI has its brain. It's graduated. Now what happens when you type in a prompt? This is where our assembly line really kicks into gear, starting with the raw materials, which are just our words.
The very first thing that happens is a process called tokenization. Now, the model doesn't read sentences like you and I do. Instead, it chops them up into smaller chunks called tokens.
Take a look at this. Super simple, right? The sentence, "I love AI," gets broken into 3 tokens: I, love, and AI. Sometimes a longer word might get broken into a few pieces. It just makes everything way more manageable for the machine to handle.
But of course, computers don't speak English. They speak math. They need numbers. So each one of those tokens has to be translated into a numerical format. This is called creating word embeddings, where every single token is turned into a long, complex list of numbers called a vector.
And maybe the best way to picture this is to think of it like a giant, super complex map of language. On this map, words that mean similar things like king and queen or jogging and sprinting, they're neighbors. They get plotted really close to each other. This is how the model starts to understand the relationships between words.
Okay, so our words are now basically coordinates on a map. But a sentence is way more than just a list of words, right? It's all about how they connect. So how does the AI figure out context? Well, this is where the smart factory at the heart of the model gets to work.
This is all thanks to the real superstar of the transformer model, something called the attention mechanism. Think of it as the model's ability to look at a whole sentence and decide which words are the most important for understanding any other word, even if they're far apart.
Let's look at a classic example that really shows this off. The animal didn't cross the road because it was tired. Now, you and I, we know instantly it means the animal. But for a computer, that's a real puzzle. How does it know it isn't the road?
And that's where attention comes in. It's the hero of the story. It crunches the numbers and figures out that it has a way stronger connection to animal than it does to road in this sentence. It literally pays more attention to animal, and just like that, it cracks the context code.
Okay, so let's recap. The model has taken our prompt, chopped it into tokens, turned those into numbers, and figured out the context. Now, finally, it's ready to write. Let's look at the prediction engine, how it actually picks the next piece for our assembly line.
So here's the thing. At its absolute core, an LLM is a prediction machine. It's playing a high-stakes game of what word comes next. If you give it the prompt, "the sky is," it doesn't know the sky is blue. Instead, it calculates the odds for every word it knows. Blue might have a 70% chance, gray maybe 20%, and something wild like falling, probably a tiny 1% chance.
But wait a second. If it always picked the most probable word, the writing would be super robotic and boring, right? To get around this, it uses a trick called sampling. This adds a little dash of controlled randomness, so sometimes it might pick the second or third best option. And that little bit of unpredictability, that's where the magic, the feeling of creativity, comes from.
So we have all the pieces of the puzzle, the training, the tokens, the context, and that prediction engine. Now for the grand finale.
How does this whole assembly line churn out the finished product?
The process is called autoregressive generation. Sounds complicated, I know, but the idea is actually super simple. It means the model writes one token at a time. It predicts the very first word, adds it to what it's writing, and then predicts the next word based on that new, longer sentence. It just keeps building on itself, piece by piece.
So let's run through that whole assembly line one last time. Step 1, your prompt gets chopped into tokens. Step 2, those tokens get turned into numbers, the embeddings. Step 3, the attention mechanism figures out the context. Step 4, the model predicts the next most likely token. And step 5, that new token gets added to the sentence and the whole loop starts over, again and again and again.
And you know, this whole process really pulls back the curtain on what this technology actually is. It is so important to remember this. An LLM is an incredibly sophisticated statistical pattern generator. It is not a thinking, feeling, conscious mind. It doesn't understand what love or sadness means. It just understands the mathematical relationship between those words and others.
Look, if you forget everything else from this explainer, just remember this one sentence. LLMs generate text by using neural networks to predict the next token based on probabilities learned from massive data. That's it. That's the secret sauce in a nutshell.
And that leaves us with a really fascinating, kind of mind-bending question, doesn't it? If this machine isn't thinking, if it's just a hyper-advanced pattern matcher, but it can still write poetry, make art, and come up with ideas that feel genuinely new, what does that tell us about our own creativity? Something to chew on. Thanks for joining me.